Hey guys, Ogre Fab Works here. Welcome back to the channel. Today's project is this exhaust, which we've got some cracks all the way around, and then focus. Got some cracks here as well. So just did a quick test, spark test, ground a little bit on it just to see how the sparks looked relative to some mild steel that I had here for another project. And it definitely looks like cast iron, which is typical for exhaust. So we'll be using some silicon bronze to patch this up, but gonna go ahead and take a carbide burr, I'm guessing, and grind that out, the crack, and fill it back up after preheat, and try to do some reinforcement. I haven't quite figured out if I'm gonna do some kind of little triangle piece right here, or can't find the words I'm looking for, but just some kind of little reinforcement to prevent this from happening, because you can see with the stiffener being right here, I think it's flexing right where that stiffener is, and that's why it's breaking. So we need to kind of distribute that force, and I think a little piece right here would really help with that. So stay tuned. We're going to go ahead and, like I said, grind this out and weld it up. So here we go. Alright guys, so I was cleaning up the crack here, but it started to move a little bit too much on me. As you can see, it's kind of flexing there, and I'm just nervous if I continue cleaning up that crack without putting a tack on it, it's going to fall off and just make life way harder than it needs to be. So I decided I'm going to press it tight and put a little tack in there. I've got the first welder I've ever bought, Miller 211. It's got some bronze wire in it, running a helper argon off this tank. I love running these dual gauges just for this reason, because I've got the one gas wire, the black one, running to my TIG welder, but now I can run an auxiliary off of it to this welder, and good as gold. I do the same thing with my other welders. I've got dual gauges on them all, because if you run out of gas on one of them, rather than messing around and having to do a whole bunch, you just take your auxiliary line and run it over, and keep welding. So just a little quick tip there on the dual gauges. And all right, enough talking. Let's throw some tacks on there and keep gouging out the crack. And here we go. Ideally with cast iron like this, you want to preheat, but I'm just throwing a tack on there to hold it, so I'm not going to weld the whole thing out. So we're just going to throw a little tack on there, and that ought to be good. So here we go. Alright guys, so that's after a bit of welding with the bronze wire. This is very, very thin, so it's really hard to keep a consistent puddle on here. You know, you may say, hey, just turn it down a bit, but it was actually so thin that when I went over it with the torch, I forget the head that you call it, the rosebud. The rosebud was so hot that, and the material was so thin, it was actually burning back where I had gouged it out. So that's how thin it is. So, but overall, that looks pretty good. I'll go ahead and clean it up a bit. But on to the next one here. So same process. I got to gouge all these out. It looks like we got a bit of a hole there. So that'll be fun to fill. But same process. So I'm just go ahead and do this one as well, and bring you guys back. All right, guys. So been gouging out the crack, as you can see. It's been going pretty well, but just a development with the hole back in there that you guys can see. I just really don't think I can get the MIG gun in there to weld that up. So what I'm going to have to do is gouge off this plate and get this out of the way. I don't know if I can. I'll have to gouge the whole thing off at both ends, or if maybe I can just gouge enough. Well, I guess I can't really. I was hoping I could just bend it out of the way, but I may actually have to remove it and then weld it back in. And then I also noticed, see if it'll focus, there's a bit of a crack just above my fingernail there, so it kind of comes from the weld across all the way to here, so I'll have to gouge all that off. So there's just cracks all through it, and I think what I'll have to do is, you know, like I said, take this stiffening member off. So I've got the plasma all set up. Just gonna try and gouge it first, see what we can do. I also find it interesting, these look like regular MIG welds. You can see kind of the wire, that looks like regular wire welded to the cast. So just a little, I wonder if this was added after the fact, or if this is factory, or I don't know. But regardless, we'll gouge it off, fill up the cracks, fill up the holes, put it all back together, and go from there. So just wanted to show you guys kind of what's going on as the repair progresses. All right, here we go. Alright guys, I'm blending it out. So you can see there's pretty good fusion there. Still got some cleaning on the spatter and stuff to go. It does look a little ugly on this side, but that's because there's a huge hole to fill. But I'll blend it up. You know, the welds. Yeah, so like these welds are a lot better, but the fit up was much better. It's really hard to you know, fill a quarter size gap and have it look pretty. But we'll blend it out, keep blending it, and it'll turn out really good. What I'm working through here, you know, I've got the big angle grinder, I've got my small roll-lock discs, and probably use this belt sander here a little bit too. Just kind of whatever fits, whatever makes sense. Try to knock all the spatter off, blend her up, and she'll look good. Alright, seems to be blended out pretty good. Got full penetration for the most part. There's a little bit of slag in there just from filling in the hole. But overall looks good. Same with this one. So now the next step is I need to add a stiffening member here, because the reason this cracked is, you know, all the weight is flexing right there. So what I was thinking was, if I can find my piece, here's a piece, something like a stiffening member here to try to limit this vibration movement back and forth, which is why it's weak. So if I can cut a piece like that, weld the top, weld the bottom, I think that'll help a lot. This is actually the piece that came off here, but I'll have to make a new one. I think it's just too short. I mean, I guess I could fill that in with weld, I don't know. But yeah, so need to make this piece and then create the reinforcing members for both sides. Then I'll probably throw some high temp paint on there and call it good. Let's keep going. Alright guys, here's the piece that I cut out, you know, to replace the tab that I'd essentially cut off. I could have gone all the way up to the top, you know, here, but I think I'm just going to do the same design. You know, place that there, stiffener, just so it's the same, so one side doesn't see more flex than the other. So since this is silicon bronze, I'm going to use silicon bronze here, but since on the back side it's steel and there's cast iron underneath, but you can see there's a bit of a gap, so that'll be steel to steel. So I'll switch fillers, so I'll do silicon bronze, steel, and then when we add the stiffeners, I think it'll be the same thing. It'll be silicon bronze on top, and then steel to steel will be steel on the bottom. So interesting little repair here with, you know, different fillers and whatnot, but you want to make sure that you use the silicon bronze or nickel or whatever it is that you're using on the cast iron. So let's keep going. Alright guys, here's the finished part. Put some high temp paint on there. So this one is a replaced member, so it's a lot thicker steel. It's about 1/8 inch. I was going to reinforce it, but I just, you know, it used to be about in this position, and I just moved it higher up, so you didn't need to put a stiffening member. And you can see the difference in thickness on that. It's a lot thinner so I reinforced it, and I reinforced it with 1/8 inch steel on there. But overall, it turned out pretty good. Again, that's all bronze, brass, whatever you want to call it, wire. You could have also TIGged it and used some nickel, but I've always found that TIG has a tendency to put more heat into it than I like, and you know, it likes a lot cleaner and a lot more prep. But either way, it turned out great. Customer's happy, and that's a wrap. Like, subscribe. I've got more videos coming out. Ogre Fabworks. I'm over in Michigan and Indiana. Thanks, everyone. Bye.